From 1889 to 1944, all units of the German army that dealt with counterintelligence, espionage, and sabotage were called the Abwehr. This word in German translation means defense. After the defeat in World War I, Germany temporarily remained without military special services. In 1920, a group was created in the armed forces that was supposed to deal only with counterintelligence, but actually became an intelligence agency. The official date of the Abwehr's restoration is considered to be March 23, 1921. In 1928, after merging with naval intelligence, the group was elevated in status to a department. In 1938, it was reorganized into the Intelligence and Counterintelligence Administration of the Supreme Command of the German Armed Forces. The scale of activity of this terrible organization, which throughout its existence wove an intelligence network in many countries of the world, is best expressed by the motto, intensive war, intensive espionage. From successful large-scale sabotage operations to transforming the Abwehr into the most important instrument of Hitler's policy, during World War II, the Abwehr became the central organ for conducting intelligence activities abroad and played a huge role in preparing and ensuring the success of Hitler's aggression against European states. The Abwehr Intelligence Service, under the leadership of Admiral Spy Wilhelm Canaris from 1935 to 1944, numbered more than 50,000 employees, both staff and freelance. The Abwehr apparatus in the summer of 1920 consisted of two groups whose activities were directed against espionage and sabotage, the Eastern and Western blocks. In 1921, the group included three subgroups. By October 1938, the central apparatus of the Abwehr consisted of 5 main departments. The first department dealt with administrative affairs, the Central Archive and Registry of Abwehr agents. The second department conducted espionage in foreign states. The third department engaged in sabotage and terrorist activities on the territory of enemy troops. The fourth department conducted military counterintelligence inside the country and abroad. The fifth department collected intelligence information through studying foreign press, radio broadcasts, and literature, processed information received from German military attachés abroad, and managed their intelligence activities. The Abwehr system included intelligence and counterintelligence organs in various formations of the German armed forces, and many peripheral departments functioned, which were called Abwehrstelle. According to a statement by the head of the second department of the Abwehr, Erwin Stotze, the Abwehr model of 1938 differed from German military intelligence of World War I times and the military intelligence of most European countries, because the intelligence services of the three components of the German armed forces, Army, Aviation, and Navy, were united in one department. Intelligence information was obtained centrally, which allowed conducting a balanced policy of development of all branches of the armed forces and contributed to a significant increase in combat capability during the war. According to records in the diary of Hans Pickenbrock, who headed the first department of the Abwehr from 1936, there were several categories of agents depending on the goals of combat use and methods of information transmission. There were peacetime agents. These were recruited foreigners, Germans who temporarily stayed in the country. Crisis period agents worked during the escalation of the internal political situation in the target country. Military agents were recruited citizens of enemy countries who were not involved in carrying out intelligence tasks in peacetime. There were also radio agents, influence agents, recruited high-ranking officials of enemy country governments, and especially trusted persons, secret freelance employees recruited from engineering and technical personnel of the largest industrial enterprises of the Reich, and military personnel. Every aspect of the Abwehr's work, recruitment methods, agent infiltration, building agent networks on the territory of individual countries, intelligence, special equipment, methods of information transmission, was thought out and developed at the highest level. To organize intelligence on the territory of countries that were of interest on the eve of World War II, the latest achievements of science and technology were used. Aerial photography of strategic objects was conducted at altitudes from 13,000 meters and higher. Reconnaissance aircraft were equipped with photographic equipment with a high degree of optical resolution, while the enemy not only could not see the aerial reconnaissance, but also could not hear it. Stop. For aerial photography and foggy weather, reconnaissance aircraft were equipped with photo cameras with infrared optics. Needless to say, by 1939, the Abwehr had the most powerful aerial reconnaissance system in the world. No other country in the world had reconnaissance aircraft with such first-class equipment as German aviation. Engineers of the technical department developed microfilming apparatus that allowed reducing a standard sheet of writing paper with text, drawings, maps, diagrams, etc., to the size of a printed dot. Information could be read using a microscope or enlarged to original sizes in projection apparatus. Mandatory conditions were the use of high-sensitivity photographic film and quality photographic paper. The Abwehr successfully used this apparatus for transmitting instructions to foreign agents. Moreover, the presence of microscopes among agents was conditioned by their profession: doctor, biologist, chemist, jeweler, etc., or their hobbies, numismatics, philately, and others. Abwehr agents for years transmitted reports from Great Britain to Portugal using the services of the Royal Mail, and all thanks to the technical department. A composition of sympathetic inks was developed that did not react with iodine and did not become visible when heated. Agent infiltration was prepared carefully and in advance. Developing a real biography for agents was always one of the most complex and meticulous types of work. A reliable legend is the key to the success of any intelligence operation, a kind of justification for why an agent is in this particular place and not somewhere else. A correctly selected profession and carefully worked out legend created reliable cover for recruited spies. For example, in France, small grocery stores, tobacco shops, and newspaper kiosks were purchased for German residents. The Abwehr, being one of the administrations of the Supreme Command, could directly appeal to the higher command of troops and request all kinds of help and support. Experienced officers from the general staff cadres were appointed as department heads, with leadership rotation occurring every 3 years. The problem of staffing with career officers was extremely acute for all departments of the Abwehr. Thus, the first department of the Abwehr recruited officers who had some foreign connections, or officers who returned from long foreign assignments. Obtaining sappers and practical experts from ethnic minorities was the task of the second department. The leadership of the third department attracted former law enforcement workers and criminologists. In 1934, a special Abwehr school was opened in Wilhelmshaven for training agents for sabotage and reconnaissance operations in Western Europe, France, Belgium, Holland. Special attention undoubtedly deserves the special equipment, spy cryptographic devices, and radio stations developed by the special services of the German Nazi apparatus, and in particular the Abwehr. Radio agents and parachute agents were provided by the technical services of the administration with the most modern means of communication and experimental weapon samples. The fastest way to transmit obtained intelligence information is radio communication. Radio stations were camouflaged as radio receivers. The Abwehr's arsenal had many ways of stationary radio station placement. For example, a radio built into a wall with a key disguised as a plug contact. During the war, radio agents operating in the deep rear of the enemy were supplied with portable radio stations with power batteries. During World War II, Rudolf Staritz worked in the drawing office of the Abwehr. Throughout this entire time, he had the opportunity to see and work with drawings and albums of electrical circuits of Abwehr radio receivers. Despite the confidentiality of the work performed and the risk of being caught, he managed to make photocopies of some connection diagrams. Some diagram stars simply reproduced from memory. By 1985, Rudolf Steritz had collected enough material to write a manuscript about radio communication of the Abwehr service. But despite the fact that his monumental work revealed a hitherto secret piece of history, he could not find a good publisher. In subsequent years, individual parts of the manuscript were published in the German magazine Funk in 1985, 1987, 1988, and 1989, as well as in 2 chapters of the second volume of Fritz Trenkel's book. In addition, the manuscript was passed to private individuals. Unlike the Soviet Union, where shortwave radio was used for the work of political and military special services from the late 1920s, Western countries began to consider the possibility of using this communication technology approximately in 1935. In Germany, the then head of the Ministry of Defense issued an order to create a radio network for defense services, for which a special department for the development and production of radio stations for agents was formed. In a subdivision of the Supreme Command of the German Armed Forces in Stahnsdorf, established in 1936, under the leadership of Engineer Kaiser, only 4 mechanics began working on the development and production of the first shortwave devices. At that time, the number of shortwave amateur radio equipment was rapidly growing worldwide, and thanks to radio amateurs, the market was developing quite actively. At the beginning of the war, many of them were mobilized or transferred as soldiers to corresponding institutions. Before the war, the Abwehr service was oriented toward English market technologies and purchased and later copied small pocket receivers and transmitters that worked from batteries using miniature lamps. Surprisingly, these miniature lamps with plug bases were not used in antenna feeder devices in England at that time. In 1937 to 1938, the first fully equipped German amateur radio suitcases appeared, which could be used by radio agents on merchant ships, conducting transmissions directly from onboard or from ports. Portable shortwave radio stations were the best and fastest type of communication between agents and the center. Radio devices, with which practically all administration agents were equipped, were manufactured and underwent bench tests in the technical department. After the start of military operations in the European theater, design engineers, after some improvements, also used captured short-wave radio stations. Radiograms were received on fixed frequencies at predetermined times. Each military district had a so-called radio studio, a disguised receiving and transmitting radio hub. The laboratory and central communication hub were located in Stahnsdorf, near Berlin. In 1943, the design bureau and production of amateur radio devices was moved from Stahnsdorf to Nischutz Castle near Wurzen. The circuits of amateur radio devices manufactured before the war or at the beginning of the war corresponded to the circuits of the simplest amateur radio devices, and today may seem quite primitive. One of the pre-war devices with the smallest number of circuits, only 3 lamps, was the Mark 7B Paraset of the British Secret Service. This amateur radio device had a frequency range of 3 to 7.6 MHz, output power up to 5 watts, amplitude modulation and telegraphy operating modes, 6 volts power from battery or rectifier, antenna, wire no longer than 20 meters. Dimensions, 280 by 356 by 640 millimeters. Weight, 1.2 kilograms. The size of amateur radio devices primarily depended on the lamps used. Below are shown the radio tubes used in German receivers for mains operation. These are ordinary lamps for pre-war designs, metal lamps when the glass bulb was replaced with steel, and so-called acorn lamps of miniature sizes. Regarding circuit technology, German amateur radio devices were so-called 2-circuit receivers of direct amplification with a frequency range depending on broadcasting range from 2 to 15 MHz. S9040 A SPY 40-watt shortwave radio transmitter of the Abwehr Secret Service was developed approximately in 1939 in Stahnsdorf for use during World War II. Starting from 1942, production was moved to Wurzen. The S9040 transmitter was often used in pair with the E90 receiver in the spy radio station SE9040. As an independent transmitter, S9040 was usually used with a high-frequency receiver such as Siemens or Radeon. The dimensions of the device in a dark gray metal case were 27.5 by 19.5 by 10.5 centimeters. Weight was 3128 grams. It was powered by an external power supply that provided 12.3 volts of alternating current for the filaments and plus 700 volts of direct current for powering the anodes of radio tubes. All controls and connections of the S9040 were located on the front panel. On the top left was the power supply connector. On the top right was the antenna current meter, and on the left were the antenna connectors. The antenna was connected to the rightmost connector and to one of the 4 connectors on the left. At the bottom left was a frequency scale from 0 to 180 degrees of the variable frequency generator. The switching device used for transmitting Morse code symbols was connected to the sockets in the lower left corner. After setting the desired frequency, the power amplifier tuning knob in the lower right corner had to be adjusted for maximum output power using the antenna current meter as an indicator. The white switch in the center is the radio band switch. The base model operated in the frequency range from 3.5 to 8.5 MHz, but other frequency ranges were also encountered, for example, from 5.3 to 9.3 MHz. Although the S9040 was sometimes used as an independent transmitter, it was designed specifically for the spy radio station SE9040. The station was housed in a rectangular suitcase covered with black leather. Inside the suitcase, there were 3 compartments, one for the power supply and auxiliary devices, the second for the E90 receiver, the third for the S9040 transmitter. A true work of art from 1942, called the miniature shortwave device operating from the mains, can rightfully be considered the SE99/10. The device, approximately the size of a cigar box, was the first German shortwave apparatus to which a small telegraph key could be connected. Depending on the operating distance, it was supplied in reception and transmission ranges from 2.5 to 5.5 MHz, from 3.5 to 7.5 MHz, or from 4 to 9 MHz. SE1093 was a spy transmitter receiver developed during World War II in 1942 in Wurzen for the German security service Abwehr. The radio station was put into production in 1943 and was used by the Abwehr as well as its successors. After the war, the device was operated by the Gehlen Intelligence Agency and even the BND. The tin case of the radio device visually resembled a cookie box, so it was often called Keksdose. The device was powered by an external battery of 1.2 volts and 90 and 270 volts, but the kit also included an additional power supply that connected to the backside. The 3-watt transmitter with crystal frequency stabilization could have up to 2 fixed channels in addition to 1 tunable channel. The receiver was freely tuned in the frequency range of 3.2 to 6.5 MHz. The transmitter 3.3 to 7.5 MHz. The transmitter was suitable only for telegraph waves and was used for sending Morse code messages using a built-in removable telegraph key. Each radio receiver was supplied with a 2-page operating manual available in several languages. The operating manual with the serial number of the radio receiver included a calibration sheet that could be used to convert the receiver's linear scale to frequencies. The sheet indicated manually the frequency ranges of the transmitter and receiver, the frequencies of additional internal crystals, and the required length of antenna wires. The dimensions of the SE1093 were 20 by 14 by 6 centimeters. Weight, only 1.7 kilograms. Controls and connections were placed on all sides of the radio station except the bottom. The case was a rectangular tin box with rounded corners. The bottom and top panels were easily removable. The left 2/3 were occupied by the receiver and the remaining 1/3 by the transmitter. On the top panel, there were 3 large holes through which the black receiver tubes were visible. The holes served for cooling. The antenna and counterpoise were connected through connectors on the top panel. The connectors on the left, on the front panel, were used to connect a 4,000 ohm speaker or a pair of headphones. All receiver controls were located on the left side panel. The on-off switch was used to turn on the filament voltage. To tune the reception frequency from 3.2 to 6.5 MHz, it was necessary to turn the rotary switch located on the left closer to the rear wall of the receiver. The current setting was displayed on a linear index scale on the top panel. All transmitter controls were located on the right side panel, where the necessary transmitting antenna was also connected. The transmitter had 1 or 2 built-in crystals with fixed frequency, which were selected using the rotary switch on the right. The SE109/3 was powered by an external battery or by an external power supply that connected to a 4-pin connector on the rear panel of the device. The radio receiver required 3 voltages: 1.2 volts, 90 volts, and 270 volts. Most SE109/3 radio stations were produced with a serial number consisting of 3 or 6 digits. The serial number was somehow encrypted, so it is impossible to accurately determine the number of manufactured devices from surviving samples. Referring to some facts, it can be assumed that about 500 units of SE109/3 saw the light. The serial number was usually written in pencil on the receiver tuning scale and could be duplicated on the front panel of the device or any other place on the radio station case in black or blue pencil. The SE109/3 was usually stored in a small plywood box covered with black artificial leather. The case was closed with 2 leather straps. A similar briefcase was also for the battery pack, which housed a 1.2 volt filament battery and 3 90 volt anode batteries. Due to the design of the case, access to the internals of the SE109/3 was easy. The top and bottom panels of the device were removed simply, like a cookie box lid. The image below shows the internal space of the SE109/3 when viewed from above. About 2/3 of the space was occupied by the receiver on the left. 3 large black transmitter tubes are clearly visible. The remaining 1/3 on the right of the space was occupied by the transmitter. The receiver and transmitter were separated by a tin panel on which 2 internal crystals were located, if they were present. At the top left was a round current transformer used to measure the output power of the transmitter. Fuses for the 1.2 volt and 270 volt lines were located in the upper center. Like any other spy radio station, the SE109/3 is an extremely rare find. Most radio receivers were destroyed at the end of World War II, and those that survived fell into the hands of radio amateurs and were most likely modified. The most miniature shortwave device for mains operation that was mass-produced during World War II was the SE100/11 radio station. The SE100/11 consisted of 3 plug-in and very flat parts: a 2-circuit receiver with tubes, a power supply, and a transmitter whose frequency was determined by an external crystal resonator with a tube. For encrypting messages, countless manual and machine ciphers were used. For data exchange between the Supreme Command and overseas units, for example in Argentina, the Abwehr used the Enigma G31, which is why it is also called the Abwehr Enigma. Closer to the end of the war, the Abwehr developed the SG41 cipher machine, which later received the nickname Hitler's Mill and was intended to replace the famous Enigma. This crypto machine is sometimes called the Abwehr Enigma because it was used by the German Secret Service Abwehr. However, it should be noted that this was not the only cipher machine used by the Secret Service. The Enigma G31 was widely used for civilian and military purposes in countries such as Hungary and the Netherlands. The machine was also liked by Germany's security service during wartime. It is important that the Abwehr used different wiring than other customers of this crypto machine. To keep the wiring scheme secret, the service ordered rotor blanks from the manufacturer, that is, rotors without wires. In addition, different departments of the Abwehr used rotors with different wiring. In fact, it continued to be called the Zählwerk Enigma since the G31 was developed based on the Enigma A28. Visually, the Enigma G31 was similar to the Enigma D, same dimensions, 4 encoding wheels, shiny metal parts. The 3 rightmost wheels were encoding wheels, with 1 reflector placed on the left. But unlike the previous Model D, the reflector moved during encryption. Successful models of Enigma G were the G312, used by the Abwehr, and the G260 of the security service. The G312, preserved from the 1940s, is a rare exhibit in the Bletchley Park Museum. In 2001, the crypto machine was stolen in broad daylight, but it was successfully returned. The table below shows the default wiring of Enigma G, which was identical to the wiring of the commercial Enigma D. The only difference was the number of notches on each rotor. The electrical wiring and notch placement are identical to the Zählwerk Enigma A28. The table below shows the wiring for the G312. Although the machine was used by the German intelligence service Abwehr, this is the only device found with such wiring. Different wiring was used for each department of the Abwehr. In March 1945, shortly before the end of World War II, Argentine police arrested German spy Johann Siegfried Becker. They confiscated an Enigma G31 model with serial number G260 from him. 2 months later, the crypto device was handed over to the Americans. Although Becker worked for the German Secret Service Abwehr, the G260 was most likely used by the German Security Service. The German Security Service had its own network in Argentina, which the Allies called the Red Network. Their copies of the Enigma G31 were connected differently than the machines that worked for the Abwehr in Argentina. From the technical description of the Zählwerk Enigma, it follows that the machine is clearly an upgrade of the Enigma D with some additional features and improvements. The most striking difference from other Enigma models is the way the rotors move. In the earlier Enigma D, as in the later Enigma I used by the German Army, the rotors moved using pawls, ratchets, and notches. As a result, the rotor step mechanism of these machines moved only forward. However, in the Zählwerk Enigma, the rotors were driven by gear transmission. The number of notches on each rotor was different. Another difference from the Enigma D was the reflector, which not only could be set in any of 26 positions, but also moved during encryption. 3 encoding rotors were mounted on a spindle, as in other Enigma models, but the reflector was no longer fixed. Standard Zählwerk rotors had the same diameter as rotors of previous Enigma machine models, such as the Enigma D. However, in the later G31 model, the rotor diameter is smaller. Most devices were supplied with only 3 Cipher rotors, which could be installed on the spindle in 6 different orders. These wheels had 17, 15, and 11 notches, respectively. It is known that some Enigma crypto machines had more than 3 Cipher rotors at their disposal. In the Hungarian army, for example, there were Enigma G31 machines with 5 such rotors. Hitler's Mill, or SG41, was a mechanical pin cipher machine developed during World War II. Fritz Menzer developed a worthy candidate to replace the Enigma G. The device was manufactured by Wanderer Werke in Sigmar Schonau on October 12, 1944. An order for 11,000 units was placed. The device most likely received its nickname Hitler's Mill due to the presence of a large handle on the right side. Unlike the Enigma, the SG41 was not a rotor machine, but was an improved version of the pin machines developed by Boris Hagelin in Sweden. Hagelin began creating similar crypto devices even before the war, which were actively used in the American Army. The SG41 was an improved version of these machines with enhancements, including irregular rotor movement, rotor displacement in both directions, which generally made the crypto device more difficult to break. Regarding appearance, the SG41 differed greatly from Hagelin's machines. The case was taller, with a large paper storage compartment at the bottom. The device was controlled using the handle on the right. On the front panel on the left was a character counter that could be reset as desired. On top were 6 rotors that could be unlocked using a lever to the right of them. After unlocking, the rotors could be set to their initial position. The SG-41 was first detected by codebreakers at Bletchley Park on October 12, 1944. According to Mavis Beatty, all they knew was that the machine had 6 Cipher rotors that moved irregularly, sometimes even backwards. Although experts later managed to decrypt several messages, during the war the machine remained an unsolved mystery, and in a post-war American report it was called outstanding. The Abwehr was called one of the most effective agencies of its time. Thanks to their intelligence data, they brought Germany many victories in battles. Unlike the SS, SD, and Gestapo, the Abwehr was not recognized as a criminal organization, although its role in ensuring Hitler's aggression cannot be underestimated. The service was often called the shield and sword of the Reich, the all-seeing eye of the Führer, and even the best intelligence service of World War II. Intelligence, in the form in which it appeared at the beginning of the war, in autumn 1939, was mainly Canaris's creation. From a small workshop, it became a large and very powerful organization. Canaris was proud of his intelligence service. But the success of the functioning of the Abwehr's external communications increasingly outlined before the admiral and his officers the real situation with the approaching catastrophe. Canaris continued his struggle with the Reich Main Security Office, which, by 1944, could not present Hitler with any compromising intelligence materials on the Abwehr. Here, everything was checked, weighed, and discussed without any prejudices or upward glances. Therefore, the secret military intelligence apparatus designed to serve Hitler's war machine also turned out to be the main witness for the prosecution against him. In February 1944, a decree was issued to dissolve the Abwehr. According to this decree, the Abwehr was divided into parts that went to various departments, mainly to the Reich Main Security Office. The head of the Supreme Command and the Reichsführer SS were tasked with transferring the Abwehr to the Secret Service of the Reich Main Security Office, which, according to Hitler's order, would create a unified intelligence system. Admiral Canaris was sentenced to death, accused of participating in an attempted coup d'état, and executed on April 9, 1945,